Hi students, welcome to the video class for the subject Automata Theory and Computability. We'll start with our first module, and in module 1 our first topic is why study the theory of computation. Why I have to study the theory of computation. First we'll discuss what is computation. Computation is nothing but a sequence of mathematical operations, or I can say sequence of well-defined operations. What do you mean by well-defined operations? My operations, it should be a simple one, a better one when compared to other, and the number of operations should be few. Why study the theory of computation? Before we go into why, we can see what is computation. What is theory of computation? Right? The theory of computation is nothing but a branch or a discipline that gives the general properties of computation, where we study the general properties of computation. It is a branch or a discipline where we study the general properties of computation. Right? The aim of this course is to understand the nature of efficient computation. Right? If I get a problem, how I can get the solution for the given problem efficiently. Right? That is dealt with the course theory of computation, right? So if I want to compute something, as you all know, I need an algorithm. I need some step-by-step procedure. So in this theory of computation, I can have an algorithm and I can have a model, right? Using an algorithm, using a model, I can get my solution. Now we come to why theory of computation. In this theory of computation, I'll be creating various models, in the field of computer science to solve a given problem. So what I'm doing in theory of computation, I'm creating a model and an algorithm to solve a given problem. So as I said, I'll be creating models. So these are some models, right? Finite automata, push down automata, linear automata, Turing machine. These are some models. Using this model, I can solve a problem in the field of computer science. Right? So all these models will be studying in one module. Throughout this subject, we'll be learning about these models only. Right? What is finite automata? First module will be dealing with finite automata. Third module is pushed on automata. Then it is linear bounded automata, and at last it is your Turing machine. We'll be studying about these models. Now we can see what is automata theory. What is our subject? Automata theory and computation, right? And now we can see what is automata theory. Automata theory is study of abstract computing devices or machines. Study of abstract computing devices or machines. When I say computing device, it is not a mechanical device, right? In theory of computation, I told I'll be creating models to solve a problem, right? So when I create a model, I'll call that model as a computing device. It is just a paperwork, theoretical study, theoretical way of solving a given problem, not practically, not a practical machine that solves your problem, right? So I'll design a model. Using that model, I'll solve my problem, right? That is my automata theory. Automata theory is a branch of computer science that deals with designing abstract self-propelled computing device that follow a predetermined sequence of operations automatically, right? So this word automata, it comes from the Greek word automata. The meaning is self-acting. Self-acting means it works automatically, right? So using that automata, I'll design a model. That model I'll call as automata. Why I am calling as automata is it follows a predetermined sequence of operation automatically. So when you learn that finite automata, you can understand this definition little more clearly. So if I take this finite automata, automata theory is, right, study of this abstract machines, right? And under this automata theory, I'm having three types of automata: deterministic finite automata, non-deterministic finite automata, and um, epsilon NFA, non-deterministic finite automata with epsilon transitions, right? So first we can see what is finite automata. What is the meaning of finite? Finite means it should have a finite number of states. What is automata? Some computing device, right? Computing, self-acting computing device, right? Automata is self-acting computing device. It should compute something, right? Then word finite means it should have finite number of states. It should have a finite number of states, right? So this finite automata, how many types I have? Three types: DFA, NFA, and epsilon NFA. And this is the definition of my DFA. What is the full form of DFA? Deterministic finite automata, right? It is a 5-tuple machine, right? When I say machine, it is not a literal machine, it is just a model, right? That model has these elements, and using that model I can solve a problem, I can compute something, right? So the first element of this model is q. Q represents the number of states. I told finite means it should have a finite number of states. This capital Q will give you the number of finite states. And next is sigma. Sigma is alphabet. As I said in the previous slide, every model will have its own language. Every model is associated with a language. When there is a language, there should be a grammar. You take English, English is a language, right? And it has an alphabet. We have 26 English alphabets. Using this alphabets, I can form a word, and using the words I can form a sentence. When I want to form a sentence, I should follow my grammar. This is how this model is also related. For every model is related with a language and a grammar, right? And this finite automata, it's related with regular language, and the grammar is type 3 grammar. So this is my automata. This is my automata. As I said, this automata will have some states. You can see finite number of states. I have 3 states, and this is my starting state. This is my final state. Final state will have double circle. And how can I identify my starting state? It will have an arrow. From left, I'll have an arrow. That is my starting state. And these are my edges, right? This edges represents the transition, right? This edges represent the transition, right? So what is the meaning of this edge? State A, it is taking one input, one as the input. When it takes one as the input, there is a transition to B. It moves to B. What is the meaning of this edge? State B, when it takes 0 input, it is moving to final state. What is the meaning of this? State A, it is taking 0th input and it is staying in state A only, self loop, right? So these edges represent my transitions. So the third is my transition. And Q naught should be your start state and F is your final state. Always the notation for my final state is double circle. Right, so this is the introduction part. What is computation and what is automata theory? Automata theory is study of abstract computing device. Right, automata is a model, right? A self-acting model. Self-acting model. Thank you.